Hi everyone, welcome to my Dynamic Maths channel. Today we'll be answering four different questions about differentiation, specifically basic differential functions. Before attempting these questions, I highly suggest you to watch my previous video about a guide to differentiation. If you're ready, grab a pen and paper and let's get started. For our first question, we have a function of y equals 5x cubed minus 3x squared plus 6. We need to differentiate y in respect to x. Before differentiating this function, we have to write down our basic equation first, which is y equals ax n to the power of n. When we differentiate it, we get a times n x to the power of n minus 1. By using this formula, we can solve the differential equation. If you have noticed, we have axn, which is a term, and in the equation we have three terms. We can separate these terms and solve using this equation together. First, we write down the equation. And then we can separate them and solve for the equation. Let's take 5x cubed. If we compare this term to this term, we can see that a is 5 and n is 3. If we get the values of a and n, we can differentiate the function. A is 5, n is 3. And n minus 1 is 3 minus 1, which gives 2. And now we will solve this equation. So a is minus 3, n is 2. Therefore, this minus 3 times 2 x to the power of 1. And 6 here does not have an x. If it doesn't have an x, we can equate it to 0. Now simplify the equation, we will get (15x squared minus 6x). Remember, this is a differential of y in respect to x. And this is the answer for the first question. For the second question, we have a function which is similar to the first question. The only difference is it has a negative power. Let's write down the basic differential function rule first, which is y equals ax to the power of n, and the differential is a times n x to the power of n minus 1. Let's write down the first equation, which is 3x minus 7 minus 6x minus 4 plus 9x. Over here, we can divide. We have 3 terms and we can divide it based on just like the previous question, and we determine what is the value of a and n. The value of a in the first term is 3 and the value of n is minus 7. Once you get those values, simply substitute them into the differential equation. So 3 is a and minus 7 is n. Then you write the x and then you put minus 7 minus 1 gives you minus 8. And then you have the second term. The second term is minus 6, a equals minus 6 and n equals minus 4. Therefore, the differential will be minus 6 times minus 4 times x minus 5. And then you have 9x. 9, the value of a is 9 and the value of n is 1. You will have plus 9x to the power of 0. And according to index law, x to the power of 0 gives you 1. Now we simplify the equation. We have minus 21 x to the power of negative 8 plus 24 x to the power of minus 5 plus 9. This is the answer for the second equation. When you compare this question to the previous question, the methods are the same except the power is in the negative form. In the next question, we have another function, but this time the value of x are in the denominator of a fraction. First, let's write down the basic differential rule. Again, just as a reminder, y equals ax to the power of n dy dx equals a n x n minus 1. So we have these functions and these terms. However, they do not make the form of ax to the power of n. This is a not straightforward function to differentiate. Therefore, we need to modify this function to give us this form. To do that, let's write down the main equation. And then, by using index laws, you can refer this to my index guide. We can convert the x from the denominator to the numerator. If we do this, the power at the denominator will become negative, which gives us x minus 1. And then the second term, the power is 3, but it will give us x minus 3 if you flip it to the other side of the equation. And the third term, power is negative 2. When you flip it over, it will become positive 2, which is x minus 2. Sorry, plus 2. Now you have a basic differential form. Now you use differential to solve the equation. So dy dx equals 6 and your a is minus 1, n minus 2, minus 7, minus 3, x minus 4, plus 8 times 2, x to the power of 1. Now we simplify our function, which will give minus 6 x minus 2 plus 21 x minus 4 plus 60x. Depending on the syllabus, some questions requires you to convert the negative 2 power to become positive, which requires you to convert it to the denominator again. So this is the answer for question number 3. Last but not least, we have another function with roots as its function. We have 3 different terms with 3 different roots. Again, let's write down our equation. Y equals axn dy dx equals a and x n minus 1. And let's rewrite the equation. Alright. So we need to convert the root of x to the power form. Again, according to the in-text guide, we need the square root of x can be rewritten as x to the power of half. The same goes for the second term. In this case, we have x to the power of 2 over 3 because our root is 3. To convert this into power form, we need to separate square root of 3 and x. Square root of 3 times square root of x. And then we convert it into the power form, which is square root of 3 times x to the power of 1 over 2. Now we use the formula to solve for the differential. Again, dy dx, we have 3 terms. We differentiate each term separately. So the value of this term, the value of a for this term is 6. And the value of n is half. So that will be 6 1 over 2 x. So half minus 1 gives you minus half, plus the second term we have a equals to 1 and n equals to 2 over 3. Therefore 2 over 3. And now when you minus 1 from this term, so 2 over 3 minus 1, it will give you minus 1 over 3. In the third term, we have a as square root of 3, and our value of n is half. Multiply by half. And x is minus 1 over 2. Now we have our function. We simplify the function. So here will be 3 x minus half plus 2 over 3 x minus 1 over 3 minus square root of 3 over 2 x over 1 over 2. Again, depending on your syllabus, you can leave the answer as it is, or you can simplify it further to remove the negative power. You will get 3 x 1 over 2, because we know the denominator, there's a fraction here, you can convert it into square root x. The same goes for this question. So that'll be 2 over 3 square root of x, not square root, cube root of x, because it has the power of 3, minus square root 3 over 2 square root of x. This will be the answer for the question. The only difference in this question is that we are dealing with square roots. You can convert the square root or any other root functions into power functions, and then use the basic differential function to solve the differential equation. If you enjoyed this video and learned something useful from it, please give a like and subscribe to my channel for more video content like this. In my next video, I'll be doing questions about chain rule. So click the notification button and you'll receive the next video about the chain rule. This is Abraham's Dynamic Maths channel, signing off.